So we're going to start talking about the colonnade and the court of Amenhotep III here. It's a temple in Egypt. So this structure features a symmetrical plan, which is typical of most Egyptian temples, and it's really massive. And the massive appearance is, because the structure is so tall, there's so much weight coming down that they had to make the columns really large and thick. But also, they did this on purpose as a design feature as well to kind of create an awe-inspiring appearance. It really projects power and authority to those that view it, and it's kind of a visual statement of the power of the Egyptian ruler. So not only is it like a design necessity, but it's also a feature that they wanted because they wanted to kind of intimidate viewers and kind of remind them of the wealth and power of the Egyptian ruler. So the Egyptians invented the column, but the Greeks borrowed the column after the Egyptians. And they refined it and kind of added their own design features to their version of the column. And if you think about the Parthenon, that whole structure is wrapped in columns on the outside. Other classical Greek temples used the columns extensively in their design. And then the Romans ended up borrowing the column from Greece, and they developed it in their own way. And so each culture has different designs for the column. But just remember that the column, it originated in Egypt, then was passed to Greece, and then was passed to the Romans. And the Roman Empire was so large at its height that, geographically, and they did so much building of structures that they really spread the idea of the column out there to the world. And that's probably partially why it survives into the present day, is because the Roman Empire picked it up, the idea of the column, and really spread it around. So we'll talk about the round arch and the vault. The Greeks and the Egyptians had to place their columns close together because the stone beams were so weak and brittle. So the space between the columns had to be really pretty tight. But when the round arch was invented, builders were actually able to make the spaces between those columns a lot wider, which led to a lot of new architectural forms. And an arch is supported by a column or a pier. A pier is just a more massive version of a column. If you extend a round arch, it becomes a tunnel-like structure called a barrel vault. A vault is basically a curving ceiling or a roof traditionally made of bricks or blocks of stone that are dressed and fitted together tightly. And they create a shell or a fabric of stone. And Roman builders perfected the round arch and developed the groin vault as well. Romans were also among the first to use arches in above ground structures. And I would actually consider the use of arches in Roman architecture to be really kind of extreme. If you see any piece of Roman architecture made out of stone, typically it's going to have arches in it, and typically multiple arches. They were kind of arch happy, actually. And they actually adopted the arch from the Etruscans. They perfected it, but they didn't invent it. They actually adopted it from the Etruscans, which was the civilization that inhabited Italy before the Roman Empire or the Roman culture that, as we kind of, were taught, developed. So the Etruscan civilization just kind of ended up integrating into Rome. So a round stone arch can span a greater distance and support a heavier load than a stone beam used in post and lintel construction. This is because the arch is just better at transferring the weight so that you can have that wider space in between the columns. And the Roman arch is basically a semicircular shape made of wedge-shaped stones fitted together. And the way it's constructed is basically you can create like a temporary structure, typically made out of wood, and then build on top of that and position the wedge-shaped stones. And then the final stone is set at the top, which is called a keystone. And once the keystone is in place at the top of the arch, you can remove the temporary wooden structure. And if the arch is made properly, it should be able to stand on its own without mortar. And an arcade is a series of arches supported and connected by columns. So this is basically what I went over. So here's the round arch with the keystone. So you would build your temporary structure under that, build up the curving wedge-shaped stones and then place the keystone in and then remove the structure. Here's a barrel vault. It's just an extension of the simple arch here. It's an extension of the arch. And here is the groin vault, which is basically kind of like two barrel vaults meeting each other at a 90-degree angle, just intersecting each other, really. And then here's an arcade, which is, arches connected by columns, a lot like a colonnade, but it's just arches. So we'll talk about Point de Garde in Nimes, France. Roman builders used the arcade extensively in this particular structure. It's found in Nimes, France. It's called Point de Garde. It's made out of limestone. And it's an aqueduct and a bridge. So we'll take a look at that. And it's one of the finest examples out there of Roman engineering. It's 161 feet tall, and it was so well constructed that it still stands to this day, which is 2,000 years later. And the top level, so like I said, it's an aqueduct. The top level carried water to a nearby city from kind of a faraway source. And the first level was used for traffic, so it was a bridge. So not only does it, is it serving the purpose of an aqueduct, but it doubles as a bridge as well. The Romans combined Greek columns with the arch, and they created a lot of variety in their architecture by doing so. The Romans also invented concrete, and this was a huge deal for architecture, the fact that they invented that. Concrete is still used to this day. It's amazing, if we didn't have that, we just wouldn't be where we are today. It's a mixture of water, sand, gravel, and a binder such as lime or gypsum. And it's a liquid first, and it's always typically poured into a form or a mold and then allowed to dry and harden. And you can create walls or vaults of any variety or shape or size. And concrete is more versatile, it's stronger, and it's cheaper than stone. And concrete allowed the Romans to cut cost and speed construction throughout their empire. And they were able to build on a massive scale due to concrete. So we're going to move from the arch to the dome. So the dome is actually based off of the arch as well. It's basically an arch that's rotated 180 degrees all the way around on its vertical axis, and that creates a dome. They can be hemispherical or pointed. I think hemispherical just means rounded, or they can be pointed. And they usually rest on a circular base or a polygonal base of some sort. And the weight of the dome actually pushes downward and outward around all of its circumference. So there are physical forces to deal with. And the simplest support is going to be a cylinder for a dome. So here's the dome, here's the forces of being pushed downward and outward. And it's basically an arch that's just been rotated 180 degrees. And then here's a dome. This is supposed to be a dome up here on an actual cylinder shape here. And that's the simplest support for a dome, is a cylinder, a cylinder base. So we're actually going to take a look at a dome construction. Hagia Sophia in Istanbul, Turkey. It's considered one of the most magnificent domes ever made. It was originally a Byzantine cathedral, and its name means holy wisdom. It was built in the 6th century, and it was basically the central sanctuary of the Eastern Orthodox Christian Church, which was early Christianity. And then eventually, after time, the Islamic culture overthrew the Christians in this particular area, and it was converted into a mosque. So that's why you can see these towers were added. And that did not originally, those were not original design features, but once the Islamic culture came in, and this was converted into a mosque, they added the towers later. So the dome, if you look at the interior shot of the building, the dome looks like it's floating on a halo of light. And that's because they added in these windows all around the base of the dome. And the presence of light is symbolic of the divine. It's symbolic of God. So it makes sense that they wanted this effect inside a place of worship. They wanted the effect of God's presence. And they did that by making it look like it's floating on a halo of light. So there's a lot of symbolism there. And this particular dome with this structure rests on pendatives over a square base. And you can kind of see what pendatives look like. They're typically, I believe, triangular shaped structures that transfer the weight into, in this case, a square base. So that's kind of how this particular structure was constructed. So next up, we're going to be talking about the pointed arch and vault. It's different than the round arch. It's later in the historical timeline. It comes in later. It's a new technology in the Western world. At the time, obviously, that's invented. It comes, like I said, it came after the round arch, and it's a very important structural advance. It became widely used in cathedrals in the Western world, and it is basically, it's an arch based on the round arch. They just added a point to it, and with the pointed arch, it's possible to build wider aisles and make higher ceilings inside of cathedrals. So that's why they used the pointed arch a lot in cathedral construction. And the fact that they were able to get these really high ceilings, these ceilings seemed to stretch on forever towards the heaven, and it created this huge, enormous space that aimed to kind of overwhelm the inhabitant as well as to inspire the inhabitant as well. The pointed arch is steeper than the round arch, and we can see some of the effects of the pointed arch in cathedral construction here. You can see that, this is where people would sit. This is probably, where sermons were given and those kinds of things. So if you look at this, you can see how that would be very awe-inspiring to the people that attended services here. And this is located in France. This is the cathedral at Notre Dame. It was built in 1145, and it probably just kept on being added to over the years until 1530. This is the interior nave, which is the main area where they would give services. The height is 122 feet, the width is 53, and the length is 130 feet. So as you can see, the pointed arch really allowed for these tall ceilings and really wide space here to get all of the people in one area. Let's take a look and see what time we have. Okay, so the pointed arch is steeper than the rounded arch, and more weight is sent directly downward, and a substantial sideways thrust is always present in these tall structures. These tall structures always want to kind of break apart this way. So they had to deal with those thrusts that were coming from the tall structures. So medieval builders solved the problem of the substantial sideways thrust by using buttresses at right angles to the outer walls. And we'll go over the buttress system a little bit more in the next video.